All right, so we're going to graph this thing by hand. And when we do that, there's some interesting things. So the other day, what we did is we just plugged in the opposite. All right. And so we're going to do a bunch of stuff with this problem, to be honest with you. I think the first thing that I want to do is I'm going to consider, I'm going to take this number here, 2x minus 2, and I'm just going to set it equal to 0, okay? And let's solve for x. And I know this is a tight fit, so I'm going to add 2 and try to cram this in on your graph. I'm going to add 2 to both sides, and I get 2x equals 2, or x equals 1, yes, good. Right, because we divide both sides by 2, and we would get x equals 1. Now let's do the same thing over here. I'm going to say 3x plus 3 equals 0. I'm going to subtract 3 from both sides. And I get 3x is equal to negative 3. So what does x equal? Negative 1, right? Now that's important. We're going to come back to that. Now I think what we're going to do also is we're going to say x comma y, and we're going to plot some points. So the first thing I want to do before I start plotting all these points is let's open up a tab on our Chromebooks in Desmos. Okay. And let's put in our function. I'm going to say f of x is equal to 2x, oops, we got to put it in parentheses, right? Is equal to, in parentheses, 2x minus 2, close the parentheses, 3x plus 3, close the parentheses, right? Now, what do you notice about where it crosses the x-axis? Yeah, it crosses the x-axis where x equals 1 and x equals negative 1. Huh. Let's plug those in. So also, remember this. We did this Friday. Click on the plus button and click table. And I'm going to plug in positive 1. Oh, wait. Remember, we got to change this up here. Remember how we did that? What did I plug in here? F parentheses x. And then when you hit the number 1, it automatically puts it down in the bottom. And so when we set this up this way, Desmos, we're telling Desmos we're going to say, hey, we're going to arbitrarily put in some x values. Arbitrarial is a fancy math word that means that we're going to randomly select numbers and plug them in. Okay. Why is Mr. Adams using terms like arbitrary? Because you might see it on the SAT. It just means to randomly select something. Something is arbitrary means it's you ran in math. It means you randomly select numbers. Okay. So I'm going to put in negative 1 and 1, and look. They both equal 0. So let's go back and write that down. Now remember, when x equals 1, y equals 0. And let's plot that point. When x equals 1, y equals 0. So we'll say 1, 0. Okay? And then also, we should probably make some notation here. F of 1 equals 0, okay? Likewise, negative 1 equals 0 as well. So we'll put a little dot right here. And that's negative 1, 0. And so we would say that f of negative 1 equals 0, okay? So now we've been looking for a line of symmetry because that's helpful. What have you guys noticed about the x-intercepts? Where does that vertex or line of symmetry usually end up? Right in the middle of the two, right? So, what is that? 0, right? I think somebody said 0. So let's try 0. So go in here, next one down here, and let's plug in 0, see what we get. -6. So what does that mean? Well, and I want you guys to plug these in on your computers. You know I'm watching the screens, right? So when x equals 0, y equals -6. And then over here we would say f of 0 equals -6. So way down here, we're going to say 0, comma, -6. So what does that mean? So on your graph, this is your line of symmetry. So draw a little dashed line. It's kind of hard to see. Maybe I'll make it bigger so you guys can see it. Make a little dashed line. That's our line of symmetry, which is technically the y-axis, right? So how do we do that on Desmos? So if I go to Desmos, how do you graph a vertical line? Does anybody remember? X equals 0, right? And also, I don't want a solid line there, so I'm going to hit the settings. I'm going to click on this circle, and hold on, I got to scroll down a little, and let me move this out of the way. I'm going to click on this circle. Nope. I'm gonna change the color, and I'm gonna make it a dashed line. Maybe we'll do it like that. Well, let me change the color that you can see. Is that good? You could change the thickness of it too. 3. Maybe I'll make it 4. I will make it 5. There we go. So that's my line of symmetry. So let's write that down somewhere. We'll say line, oops. I do that every time, don't I? Line of symmetry x equals 0. Okay. So then if I want to finish this, I want to get a point somewhere up here to kind of get a good idea. So what value do you guys want to plug in for x? If you were guessing. 3. -3. Let's try it first before we graph it. So let's go over here. -3. Oh, that's pretty big. That's 48. That won't fit on our little paper graph. So what else should we try? Let's try -2 and see what that does. Ooh, that's still pretty big, right? We could do like 1.5, right? Let's see what that does. 7.5. And we could do positive 1.5, I think would be the same. Yeah. So that's a little wonky, but it is what it is. So let's graph those. So at 1.5, which is between 1 and 2, we've got a 7.5. So they're right about here, right? 7.5 is between 7 and 8. And 1.5 is between 1 and 2. So we'll say 1.5, comma 7.5. That's a point. And then over here, 1.5, -1.5 is between -1 and -2. So we'll call that -1.5, comma 7.5. And we'll graph this. And so I like to start with the x-intercepts and just kind of swoop through the vertex. And this is not the best graph. This is kind of hard to do on this big screen the way Mr. Adams does it, but it's okay. You guys will do a much better job than me. And then this goes through here. And you know what we should do? Let's label this as the vertex. So this is the vertex. Now I only have one other thing to do that I want to do, and that's to multiply these out and see what the function is. So I'm going to take, and down here, I'm going to make a little 2x2 grid. And I'm going to multiply 2x minus 2 times the quantity 3x plus 3. I'm going to zoom in because my handwriting is not the greatest. So what's 2x times 3x, guys? 6x. What's x times x? Squared. All right. Now what's negative 2 times 3?
Negative 6.
Then you tack on the x, right? X is just x. Now what's positive 2x times positive 3?
6x.
6x. Positive 6x. I'm going to write the positive down. Okay. Now what's negative 2 times positive 3? Negative 6. So I've got on this line, I'm going to say 6x squared minus 6x plus 6x minus 6. What happens when I go to combine like terms?
6x's cancel out.
The 6x's cancel out, and I'm left with 6x squared minus 6. Oh, that's interesting. Now, how can we verify that we multiplied that out correctly? Just plug it in decimals. So the last thing I want to do is I'm going to come down here and let's plug that in. We're going to say 6x squared minus 6. Hey, that goes right over the other one, doesn't it? Let me change the color so you guys can see that. See that? So when I turn that off,